Okay, part 6 is factoring where this is a 1 in front. So I'm going to take this example. I've got k and a k. And what factors of 20? I could put 1 and 20. Well, 1 and 20, when I add them together, where this is a negative and this is a plus, it gives me negative 19. It doesn't give me negative 1. If I take a positive 2 and a negative 10, it gives me a negative 8. Again, that won't work. If I put positive 4 and negative 5, that will give me a negative 1. So I'm going to put a plus 4 and a negative 5. When I cross that, I get negative 5k and plus 4k, which definitely gives me a negative k. So my factors for this are now k plus 4 and k minus 5. And I'm going to do the same thing with this one over here. I need to get factors of 21 that when I add them together, I'm going to get a 10. If this is a plus, that means the factors of this either have to be both negative or both positive. If they were both negative, this would not be a positive. So I'm going to check them for both positive. 1 times 21, if I add those two together, I do not get 10, so this one won't work. If I take 3 times 7, if I add those together, will I get a 10? And it does work. So I'm looking at m plus 3 and m plus 7. If you multiply this out, you should end up with this product. Now this one is a little more complicated because it actually has where you have another coefficient, it's not necessarily 1. So what I've got to do is I've got to look at the factors of 2 and the factors of 3. So 2 is 2x times x, and the factors of 3 are 3 and 1. Now I could have also written it like 2x and x and 1 and 3. And I've got a minus, so one of these has to be a plus and one of them has to be a minus. And let's see which one is going to, if I put this as a plus and this one a minus, let's see which one's going to give me a negative 5. I cross multiply, I get negative 2x, positive 3x, this gives me an x. That's not what this term is, so I'm going to ignore that. If I come over here, I get a negative 6x, and I get a positive 1x, and that definitely works. So my factors are going to be these times these. So I would actually write 2x squared minus 5x minus 3 equals 2x plus 1 and x minus 3. And this will now be my answer. Now if I do one of the ones that are in your packet, I'm going to go through the same kind of concept where I'm looking at making sure that I can factor them. I'm going to look at number 4. If I look at number 4, it says 7a squared minus 11a plus 4. So what I'm going to look at is 7a and a. Now I'm going to start off with 4 and 1. It also might be 2 and 2, 7a and a. And I've got this being a positive, so they have to both be negative, both be negative. So let's see which one is going to give me a negative 11a. If I multiply this together, I get negative 4a, and I get negative 2a, and that gives me a negative 16a. So this one will not work. So let's try this one up here. If I multiply this out, I get a negative 7a, and I get a negative 4a, and this one does give me negative 11a. So here are my factors, which you must write 7a minus 4 and a minus 1. That becomes my answer. Before I start looking at a greatest common factor, I need to look and say, look, these two are like terms. So let's add those together before we factor. Now what I've got is an x that's in both, and I have 3x plus 5, and I have factored it. If I multiply this out, x times 3x, I get a 3x squared, x times 5, I get a 5x, and I am all done. But if I look at 10, 10 is putting everything together. And on 10, what you want to do is you want to actually look at this and go, you know what? I'm going to put in part 10 and 11 all the things that we've done. The first thing we should always look for is the greatest common factor. We should check to see if it's a difference of two squares. Check to see if it's a perfect square. So here's an example. 5 goes into every single one of these. So I'm going to factor out the 5 first. Now I have an x squared plus 4x minus 1. And I don't think there's any way I can factor this out any further because the factors of 1 are 1, the factors of 1 over here are 1, and there's no way I'm going to get a 4, so I'm done. But if I had one that could actually factor some more, I would do it. Here's another example. I've got a 5x squared plus 20x minus 60. 5 goes into every one of these, so I will factor out the 5. I get an x squared plus 4x minus 12. Now I have to look here and say, what are some factors of 12 that a positive and a negative, when I add them together, will get me a 4x. So let me try 1 and 12. That won't work. Positive 2, negative 6. That will give me a negative 4. So let me try a negative 2 and a positive 6. That will work. So now what I have here is I've got, and there's a couple ways to do this. I can go down here and go x and x, negative 2 and 6. Cross, I get a 6x. Cross, I get a minus 2x, and that gives me a 4x. So now here are my factors. And they end up being 5 stays here, and I get x minus 2 and x plus 6. And that is my final answer. I have now factored it all the way down. It is one that actually says, it's got 4 terms, so I know I can't do anything but grouping. And if I look here, 2 goes into these 2, but nothing really seems to go into these 2. So what I'm going to do is rearrange it. Why don't I rearrange it as 6ax minus 3a minus 2b plus 4bx. Now what I'm going to do is I'm going to look at dividing it here, and I've got a 3 that goes into both of these and an a. So I'm going to take out a 3a. Now I have 2x minus 1. I have a 2 that goes into these, so I'm going to say minus 2, and I also have a b. Well, if that's the case, I get, let's do a plus 2. I get minus 1, and I get plus 2x. These are almost identical, and if I don't recognize it, I'm going to rewrite it so that you can see how identical they are. And now, what I've got here is this blob and this blob. Those are identical. And what I have left is 3a plus 2b. Now I've got it completely factored. If I multiply it out, I should get back to this value. If you want to do section 12, it will be extra credit.